Hey, so I'm Billy Sharnon. This is my chemistry SRP project. It's on steroids, specifically comparing the chemical formulas structure and then a little bit about how they react in the body. So to start, all steroids are made to mimic natural testosterone. Natural testosterone has 19 carbon atoms, 28 hydrogen atoms, and 2 oxygen atoms. Just looking at that kind of structure, there's a very little amount of oxygen atoms, largest amount of hydrogen atoms, and then carbon is in between on the little bit higher side. Most steroids will follow this general pattern. For example, an extremely close to testosterone is testosterone enanthate with 26 carbon atoms, 40 hydrogen atoms, and 3 oxygen atoms. It's a little bit more atoms there, but it's on the higher side, with that still following that general that general guideline. These next two, nandrolone and oxandrolone, both are very, very close to natural testosterone. 18 carbon atoms, 26 hydrogen atoms, and 2 oxygen atoms in nandrolone. That's just 1 less carbon atom and 2 less hydrogen atoms. Oxandrolone is 19 carbon atoms, 30 hydrogen atoms, and 3 oxygen atoms. This one has exactly the same amount of carbon atoms, just 2 more hydrogen atoms and 1 more oxygen atom. Those two are extremely close. And then these next 3 just follow that general guideline, just like testosterone enanthate. Trenbolone acetate has 20 carbon atoms, 24 hydrogen atoms, and 3 oxygen atoms. Menthandienone has 20 carbon atoms, 28 hydrogen atoms, and 2 oxygen atoms. And then oxymethylone has 21 carbon atoms, 32 hydrogen atoms, and 3 oxygen atoms. You can see every single one follow that general, very low, 2 or 3 oxygen atoms, carbon, a little bit in between the oxygen and the hydrogen. Hydrogen was on the higher side. And then the structure of these are also all extremely similar, following that general pattern in the formula tends to be very close. So just good example, natural testosterone compared to testosterone enanthate. They are almost identical in shape. The main difference is, testosterone enanthate has 7 more carbon atoms and 12 more hydrogen atoms, and then that 1 more oxygen. So it has a little bit more to work with. So the base of both look almost identical, and then the testosterone enanthate has a little bit of a tail coming off the back. Still makes it a very similar compound. Basically looks identical if you were to take away that tail. So then all of these steroids fit into one of 2 types. There are 17 alpha alkyl derivatives, such as oxandrolone or oxymethylone, and then there's 17 beta ester derivatives, such as all the different testosterones, like testosterone enanthate, and then other things like the nandrolone, as listed before. So how it works in the body is the testosterone, when injected, is in much higher volumes than what you would normally have in the body. So it binds with these androgen receptors and reacts with all the enzymes in them, and just has them fire and telling them, hey, we got to make more of you. And what these androgen receptors do is they tell the body we got to protein synthesis and then tissue repair are the big 2 things. So with more of them, you're getting more tissue repair, better protein synthesis levels, which are the basis of what steroids do. So chemical reactions of these testosterone in the androgen receptor cause like a chain reaction, and eventually ends in a ton of androgen receptors in the body being extremely efficient with protein synthesis and the way that your body repairs itself. There are other things that happen. Sometimes there are weaker androgen receptors, and then they have the body make estrogen, which does the opposite of what testosterone does. So, there's a lot of chemistry behind how it works, but that's kind of just a touch. So that was my SRP project. Just a little bit of a slight look into how steroids are formed chemically, how they react, and then some structures. Thank you.